Hey everyone, today we're looking at the paper BigBird, Transformers for Longer Sequences by a bunch of authors from Google Research. The transformer model from 2017 has been applied to a wide range of sequence modeling tasks with a great success, such as translation, summarization, question answering. It also has been used for pre-training on raw text, resulting on very good performance on various downstream tasks. And this has been done by models such as BERT, Roberta, and so on and so forth. The transformer architecture is based on the concept of self-attention, illustrated in this example here, where you have a sentence about the American governments which have passed new laws since 2009. Self-attention applies a series of word-level comparisons. Basically, it's doing n to the power of 2 comparisons, comparing each word in the sentence, in an input sentence, with each other word. For example, making a comparison of making to itself as well as making to 2009, making to difficult, making to it, and so on and so forth, and doing multiple of those comparisons in parallel and combining the results. So this works very well for short sequences. However, if you would like to apply the transformer to longer sequences such as scientific paper or so, very long articles, you're starting to face various challenges, in particular high memory usage due to this n to the power of 2 comparisons, because you have to store these comparisons in memory. And because of this, transformer models have typically been applied to shorter sequences. For example, BERT was limited to sequences of length up to 512. So this limits the application of the transformer. For example, if you want to do summarization of scientific papers where you have, let's say, 5,000 tokens in the input, you cannot really apply that. Or what people are doing is they chop off those input articles only to accept the first 512 tokens, which is not really a way to go, especially if you have features scattered all over the place in this input article. In this paper, BigBird, they propose a new sparse self-attention mechanism which reduces the n to the power of 2 comparisons to linear, to do only n word comparisons, which makes the transformer approach or the self-attention models much more scalable to long sequences. There have been a number of similar papers published in the last year or two, but I guess what's different, or I guess new about the BigBird model, or I'm not so familiar with all of them, but the BigBird approach is consisting of actually 2 sub-approaches which are combined to make this sparse linear attention work. The first is to basically not do comparisons for all the words, but to randomly pick kind of words to compare. For example, this is if we imagine the same sentence here about whatever the American, whatever election and so on, I don't remember what it was, American governments. Let's say you have this, on the x and the y axis here, you have the sentence and you're doing a comparison. You're not going to be comparing each word to each other word, but you're only going to pick words at random to do comparisons. This is one component. Another component is to do a comparison as a window, so to only compare nearby words. And then a final component that seems to be pretty important to this BigBird approach is to introduce some, let's say 2 special tokens in the beginning of this sequence, and to compare all the words to those beginning tokens. So, and then the final BigBird model is actually combining all of those approaches together into the same model and resulting into roughly a linear self-attention model. And in the paper, the authors spent some time discussing, basically proving that there's some theoretical basis to this approach, and they claim that BigBird is going to be having in terms of expressiveness, is going to be at least as powerful or similarly powerful to the standard self-attention model. I'm not going to cover that. I encourage you to take a look at the paper if you're interested. But because of this sparse attention, they're able to apply this BigBird model to increase the, to be able to take care of sequences up to length 4,000, which is much larger, 8 times larger than the 512 of the BERT model, for example. They also do a number of empirical experiments. For example, here we have some question answering results on a few data sets where they take a Roberta checkpoint and then they fine-tune it further using the sparse attention of BigBird. And basically it seems that the BigBird is able to preserve the accuracy of this Roberta checkpoint, performing better across all of those benchmarks, Hotpoint QA, Natural Q, Trivia QA, WikiHop, and so on. All of those, as far as I'm aware, require some operations on longer sequences, maybe some combination of facts in distant positions of the input information to do this question answering. And this BigBird, it seems to be performing better than the base Roberta model, as well as Longformer, which is another approach to this sparse attention published a few months ago. The authors also apply BigBird to summarization on some long input and output benchmarks, such as scientific papers generating the abstract from the body using arXiv or PubMed papers, as well as summarizing patents. They test a number of benchmarks such as LSTM, extractive summarization benchmarks, some base transformer benchmarks chopped off at 512 tokens, as well as some Roberta, whatever benchmarks, as well as Pegasus, which is the state-of-the-art summarization model as far as I'm aware. And their best model is taking a Pegasus checkpoint and then converting to the sparse attention of BigBird and then fine-tuning on that task. And that one seems to be outperforming across the board on those benchmarks. All the other models on average by 5% better than the previous state-of-the-art or so. So this is another proof that BigBird seems to be effective at those long input and output sequence benchmarks. In the paper, the authors also do some benchmarking on genomics data, which I'm not going to cover, but also is requiring processing of long sequences. So to sum up, BigBird seems to be a good approach to sparsifying the self-attention with some theoretical guarantees discussed in the paper. You can take a look if you're interested in that. It achieves good performance on various tasks that require dealing with long input and output sequences. And I'm curious to see what sort of applications we can see of this BigBird in the future. Longer articles, maybe even, who knows, multiple articles, maybe multi-document summarization. We're going to see maybe even processing of whole books, who knows. With those big GPUs, maybe we are getting closer and closer to getting there. So that is all. Thanks for listening, and please subscribe for some more upcoming NLP videos.